values are going to be. So for the original y equals x squared, you might have x, y. You might have points like -3, 9, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, 3, 9. You don't have to put so many points, but that's your original. For your inverse, my original was -3, 9, so my inverse will be 9, -3. My original was -2, 4, my inverse is going to be 4, -2. Instead of -1, 1, it'll be 1, -1. 0, 0. 1, 1, 4, 2, 9, 3. So the idea of you guys memorizing your 8 key functions with the table of values, if you can plot the original, then you can plot the inverse. Here's what the original would look like. -3, 9, +3, 9, -2, 4, +2, 4, -1, 1. There's my original parabola. Okay? Now, to plot this one, just use the points. So 9, -3, 4, -2, 1, -1, 0, 0, 1, 1, 4, 2, and 9, +3. Your original opens up, your inverse opens to the right. Is the inverse a function? Why not? So, inverse not a function. Because it fails the vegan line test. Vertical line test, sorry. No offense to anyone who's vegan. So you've got the graph, you've got the inverse. You want to state the domain and range of the original and the domain and range of the inverse. So domain and range of the original. I'll put the domain and range here. The x element of R is my domain. My range, y element of R, such that y is greater than or equal to 0. You see this up branch and the down branch? Well, when you find the equation, we'll have a plus or minus. The plus part applies to that. The minus part applies to that. So the question is, how do we find the formula for the inverse relation? So I'm going to show you that right now. So we've got y equals x squared. Then you switch x and y. So x equals y squared. And you solve for the new y. That's why this looks exactly like the root graph. This is the negative. So you see the plus or minus? The plus, the positive square root is the top branch. The negative square root is the bottom branch. This inverse is not a function. In the textbook, they can ask you, how can you restrict the domain so that the inverse is a function? So if you look at it, what makes this not be a function is it fails the vertical line test. If you wanted to restrict the domain, you could say, okay, just x greater than or equal to 0, because you'd only have the right half of the parabola, and when you inverted it, it would be the bottom half of the parabola. And it would still be a function because you wouldn't have the top branch. Or you could choose x less than or equal to 0, just have the left branch, and when you invert it, it'll be the right branch. Okay? So I'm going to try and find the inverse relation for this first. I've got the function f of x equals blah, blah, blah. First step, I'm going to write it as y equals the expression they gave us. Then I'm going to take everywhere I have y, I'm going to write x. Everywhere I have x, I'm going to write y. Then I'm going to solve for the new y. So I've got negative 2y plus 1 squared equals x minus 4. I'm going to divide both sides by minus 2. This will give me y plus 1 squared is equal to x minus 4 over negative 2. And then I'm going to take the square root of both sides. And so y is going to equal negative 1 plus or minus radical x minus 4 over negative 2. Therefore, f exponent negative 1 of x, the inverse relation, will be negative 1 plus or minus radical x minus 4 over negative 2. So it looks like horizontal compression by 2, a reflection, and then, so I'm going to plot this. Any questions on this before I move to actually plotting the function? Okay. So when I go to plot this function, my original function is at negative 1, positive 4. That's my vertex. Okay? And my a value is negative 2. So instead of 1, 3, 5, it'll be negative 2, negative 6, negative 10. So I'll go 1 to the right, 2 down, 1 to the right, 6 down, 1 to the right, 10 down, and that's off the graph. So I'll go back and put the other ones here. So my original might look like this. So what are those points again? Well, I've got -3, -4, -2, +2, -1, +4, 0, +2, and 1, -4. So when I go to graph the inverse, x and y flip, and I'll have -4, -3, 2, -2, 4, -1, 2, 0, and -4, 1. -4, -3, 2, -2, 4, -1, 2, 0, -4, +1. So my original graph opens down, down is negative. My inverse opens left, left is negative. For the original, the domain is x is an element of R. The range is y is an element of R, such that y is less than or equal to 4. For your inverse, your domain is x is an element of R, such that x is less than or equal to 4, and your range is y is an element of R, so I've got my original function there. So I've got s and t. So I can write I interchange t, my independent variable, for x, and s for y. Okay? Everywhere I have y, I'm going to write x. Everywhere I have x, I'm going to write y. And then I'm going to solve for the new y. So I've got x minus 0.18 Then to solve for y, I'm going to take the square root of both sides. So where it says determine the model that describes time in terms of the surface area, that model is going to be s -1 of t s -1 of t is going to be equal to 6 plus or minus radical t minus 0.18 over negative 0.005. That's the model. Because it's describing time in terms of the surface area. So we have S of t, the original. The domain is x is an element of R. The range is y is an element of R such that y is, it's opening down, less than or equal to 0.18. For the inverse relation, the domain is x is an element of R such that x is less than or equal to 0.18, and the range is y is an element of R.